Hey, Melissa.
Yeah, what's up?
The people have questions,
Oh, okay.
and they will not take no for an answer.
Okay.
We've got folks asking questions about conductors and superconductors, semiconductors, skunks,
Yeah.
why minty things feel cold and spicy things feel hot,
Nice.
microplastics. We've got a lot.
Okay. Should
So
we just do it?
I guess the question is, are you ready?
Oh, I'm ready for it.
Okay, let's do it.
Boom, boom, boom. So Taylor Swift reference. All right, let's dive in. Hey, I'm Melissa,
I'm Jam,
and I'm a chemist,
and I'm not.
and welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
And this is our bonus.
Bonus. Ask a chemist.
What up? What up? Chemistry support.
Ballin'. So this is chemistry support where the chemistry problems you're having, you get to ask this chemist right here about them. You're asking, I'm going to kind of ask for you just kind of how it works.
Yeah.
So, sorry about that. Sometimes I misread things. Sometimes I misread your questions. Sometimes I misread your name. And I'm very sorry about that ahead of time. But these are some great questions, so we are really thankful that y'all sent these in.
Yeah. I love hearing from our listeners.
And you've kind of broken it down into some sections, which is super helpful. This is kind of cool. So this first group of questions are from our chem community, folks in our Patreon community on patreon.com/chemforyourlife. And so these folks are names you may recognize. They ask questions frequently, and it's super fun. So you ready for the first one?
Mm-hmm.
This first one is from Kyle M., a community member, as I said. Semiconductors, and the question that we asked them was, what have you been wondering about this week? So Kyle said, semiconductors and superconductors. That's what he's wondering about.
Okay, well, Kyle, I don't know much about your background, so I don't know what you already know and what you don't know about those. And you didn't ask a specific question, but I guess we just asked what you were wondering about.
Yeah, and you told us.
And you did tell us, so that's it, and I won't respond. No, I'm just kidding. So it's something that I think is interesting. So conductors are things that are able to conduct electricity. And semiconductors, they can usually be like adjusted to how you want them to conduct electricity. We've done episodes on this before. But something I remember learning that I thought was really interesting is you can take semiconductors, like say we have silicone and we want to add either more electrons or have less electrons to make them act in a certain way. You can do something called N-doping and P-doping, which is where you add different impurities like other atoms to it, and then they will have different conductivity properties by basically messing up the purity of that compound. Isn't that interesting?
Wow. Yes.
And then superconductors, I don't know very much about them except that they basically conduct electricity perfectly. Like they don't lose any electricity at all.
Wow.
And a lot of things you lose some of the energy in the act of moving it across the substance. You know, it's like electrons are moving with a certain amount of energy, but like that movement requires energy, which takes away some of what's going to end up where you're going, you know? But superconductors don't do that, but I don't really understand how that's possible. And I haven't looked, and I have a rule that I don't research a ton. These are just like my instinct chemistry responses.
Yeah, because the research ones end up being full-on episodes.
Yes.
So, which take quite a bit of that from Melissa.
Yeah.
For like 99% of them. Superconductors, is that what's in like microchips and stuff?
I think usually semiconductors are in microchips.
There we go. Got it. Okay.
I think so. Yeah. I think we have semiconductors in microchips, but I don't know what superconductors, I don't know much about them.
Yeah.
So.
Interesting.
That's helpful.
Interesting. And here I thought it was just different kinds of people who drive trains. You know?
You are in a specific mood today, and I love it.
It was funny because like when you're a kid, conductors, yeah, that's what they are.
That's what it means. Yeah.
You know?
And you're around kids, so I guess that's on your mind more.
Yeah. It kind of, yeah. I guess I'm dematuring. I'm becoming more and more kid-like. This next one's also from a community member, Vince. At some point, I got an urgent call from a family friend asking for my help as a chemist.
Oh, yeah. Vince is a chemist.
Nice.
And this is also in response to the what we're wondering. What are you wondering about?
What are you wondering about? Her child had eaten one of the packets that are included in various products labeled "Do Not Eat." I asked if the child had swallowed the packet, and he had. I told her that was good. This answer upset her even more, but I explained that the silica gel in these packets is non-toxic, but kids might choke on the packet itself. She wanted to know what kind of world we live in that requires harmless substances to be labeled as if they are poison. I had no answer to that.
Vince is funny. I appreciate his reflections on the world. So silicone dioxide is what's in those packets that are labeled "Do Not Eat."
Mm-hmm.
And they're pretty porous, so it's good at absorbing water.
Right.
So they serve as what we call a desiccant. So they're supposed to absorb water.
Mm-hmm.
So they like it keeps papers from getting moldy, or like shoes from, like anything from taking on water in a way that it shouldn't.
Mm-hmm.
So the thing is, they're just silicone dioxide, though. And can you think of anything else that's silicone dioxide? Sand, yeah.
Okay.
So if you eat sand, it's fine.
Right. But you would still say this is not for eating.
It's not for eating. It's not good that they ate it. It's good that in that case, that the child was able to take it and not choke on it.
Right.
But it's not something that you want to eat. You don't want kids to eat it. And it really, I've wondered about this, where it's like, it's not toxic. It won't really do anything. But like, does it absorb?
Mm-hmm.
They don't get big like Orbeez where they absorb a lot of water or anything. But like, could it maybe cause some irritation or something if it absorbs too much water? But silicon dioxide is really interesting because we all interact with it as sand, and then it's in those desiccant packets. Where it absorbs a lot of water. And then you also will use silica, like pure silica. Is it silicon dioxide? For columns too, which is like something in the lab. And it's in this really fine powder. Now I'm guessing if it's just plain silica. But it's in this really, really fine powder. And it can, like, if you inhale it, it can cause problems as well. So it's like this... Now, I don't know for sure now what that's made out of. My brain is playing tricks on me. But it's like the same thing that you see in different spaces can impact you really differently. And so you have to consider it.
That makes sense. I feel like another angle on this from the non-chemist perspective, but more the like companies making products perspective, is there's all these kinds of things we're used to seeing labels on and stuff. And it makes you think like, okay, I'm a beef jerky company selling this bag of beef jerky. Everything in this bag is edible except for this thing.
Yep.
And if I don't make sure that everyone who buys this knows for sure that this isn't really food, if some weird problem happens, or maybe it's because of the result of a lawsuit or whatever, they just need to do it. It's just the same way. It's like, so many packaging things say this is not a toy. Don't let kids play with this plastic bag.
Yeah.
It just feels like, I wonder if that's what's on these companies' minds.
You could be like, there's a little treat here. And it's like, no, don't eat this.
Yep.
But yeah, I do think the choking hazard is one of the bigger concerns.
It's like, sure, this has been hanging out near the beef jerky a long time. It might taste a little like beef jerky.
Yeah.
And so understandable, but don't, because this isn't beef jerky.
And I think it's hard, so it could like break your teeth.
Yeah. It's like you can tell that this is different than the thing you're just eating.
Yeah.
Right? But
I did look it up, and the silica that we use in the lab is silicon dioxide. So it's like in that form, it can be really harmful. Breathing it in, it can be dangerous. You have to wear a mask because it's such a fine powder, And then in sand, it's totally safe. And then this, desiccant is like, it's probably fine, but it's not what you want your family to be eating, So yeah, I thought that was a good reflection. I'd never thought about that or chatted about that with y'all before. So.
Also, I liked the way that Vince's story went.
Yeah.
It's like, I told her good. This was upsetting to her. Like,
yeah. I can hear him saying that.
That's so funny.
Vince had a surgery earlier this summer, so I want to send our well wishes to Vince. Hopefully your recovery is going great and you're in the more mobile phase now.
Yeah, let us know. We'll have to catch up with Vince soon. Ready for the next one? Yep. It's from Tim, another community member, and I'm going to try my best to emphasize and mimic his enthusiasm. That's the way he wrote this question.
Nice.
Why do mints feel and taste cold? Why do peppers feel and taste painfully hot? And further, why does capsaicin only seem to activate the what's that word? Nociceptors? Or is that a typo?
I think it's the receptors, just the receptors
in our mouths and not our skin. Oh, I feel like we did. Did we talk about this one?
We did talk about this one.
Okay.
So we talked about half of this. So we have an episode about capsaicin and why it feels hot. Mm-hmm. Why do peppers feel hot? And essentially, the receptors that like our pain receptors are the same as our heat receptors. Mm-hmm. And so the capsaicin activates it being like hot, activates the pain receptor, even though there may not be pain happening alongside the heat receptor. So we talked about that. And we did talk about how there are other places in your body. Well, one, you can feel sometimes heat. Like I can sometimes feel capsaicin on my fingers.
Yeah, I was going to say, like, I can around my mouth. Mm-hmm. You know, it's like not on my tongue, but just like, oh, some of the spicy sauce or whatever.
Yeah.
It's like it seems like it happens everywhere.
And if anyone has had the phenomenon, what I like to call of a spicy poo.
Right.
There seems to be pain receptors there too.
Mm-hmm.
Or at least something there. But then we haven't talked about the other thing, which is mints feeling and tasting cold. Mm-hmm. And I think it's actually a similar thing where I think the menthol activates the same receptors that the cold would. And so you get both of those effects kind of opposite each other. Mm-hmm. So that was a good question, Tim. But, I was also going to say the hot feeling works in other places because I think icy hot uses capsaicin. And so, like, if you rub it on your muscles and it gives you that feeling of warmth, the blood is rushing to that area, you know. So, yeah.
Yeah. Also, I was having such a strong deja vu. I look back and we did use that question in the previous Q&R that we did.
Oh, no. Should we cut it out?
No, I think it's okay. I mean,
did we talk about that?
I was like, why am I having such a hard time with this? Like, the deja vu is really strong. And I just scrolled back. And it's been a little while since we did a Q&R because we did the other one. He must have submitted it early enough. But the September bonus, it's right here.
Oh, no.
It's okay. I mean, Tim got 2 shout-outs, so I think.
Yeah.
I think he earned them, too. So.
Whoops.
It's okay. I almost didn't say anything at all, but I was like, this is just funny, and there's probably a chance that somebody's sitting there thinking, deja vu. Like,
yeah.
You know.
Well, we didn't address the second half of
right.
Tim's question, so
yeah.
sorry that we did this twice.
No, it's great.
My brain.
No, and the second half is like, I said the thing about fitting on my lips. I was like, did I say this? Like, what is going on?
I didn't have that sense at all. There's a peek behind the curtains. Mm-hmm. I'm trying to, keep my job going and keep my life going and keep this podcast going. Mm-hmm. And so I'm just in survival mode and I didn't even notice. Sorry.
But you're right. We didn't talk about the second half. You're right about that.
What'd you say?
You're right. We didn't really talk about that second half.
Yeah.
Ready for the next one?
Yeah. Let's do it.
This section of questions is from Instagram. This is, Sienna or...
I think it's Sienna.
Yeah, we've talked about her name a couple times. Sienna asks...
Yeah, she's always asking questions. Let's just take a moment to shout out Sienna for your great questions. That they really make these bonus episodes fun for me.
100%. And this one is really a good question, as usual. What is the chemistry behind skunks? How are they so potent?
Sulfur compounds smell really bad to us, and I think skunks have sulfur compounds. They're called thiols. I think scatol, I think also. No, it might just have a nitrogen, but the one we talked about for the poopery episode, we talked about definitely hydrogen sulfide. Let me look back up the scatol structure. No, scatol does not have it. It has a nitrogen. But I wouldn't be surprised if there was some scatol in that as well. But my guess is that the main thing on skunks is thiols. But I would love to do an episode on this. I think that would be a really fun one.
That'd be super cool.
Yeah, great question.
Oh, and if we do, I don't know if it needs to be 2 separate episodes or not, but it could be the same, or you'll probably determine that as you go through the research. Could it be that we also spend time talking about the various ways people say to get rid of skunk smell?
The remedies,
Mm-hmm.
yeah.
There's a bunch of those that are like, people swear by, but it is like, knowledge has been passed down.
Yeah.
It's like, why is it that people say tomato juice is good at that or whatever?
Okay, I'm going to write down what is skunk smell and how do we get rid of it and how do we not. I've written it down on my to-do list.
Man, that'd be so cool. This next one's from Bird Speak Labs. Do you know who that is?
No.
That's Jay.
Oh, really?
Yep. Mm-hmm.
Oh, that's fun.
Jay, friend of mine, and we also used to get to work together back in the day. And we didn't realize this, but our kids are in the same little school program this year.
That's fun.
It's one of those fun, we got there on the Meet the Teacher Day, and I was like, hey, dude, what's up? So
nice.
Jay asked, I've been hearing a lot about microplastics.
So I have been in communication with a microplastics person that I would like to have on an episode. It's just hard for me to coordinate that, but I have been talking with someone who is interested.
Nice.
So I'm hoping to have an episode on microplastics incoming.
Nice. That'd be so cool.
I also am hoping to have a forensics episode incoming.
So when you say you have a microplastics person you've been talking to, is this like a very small person made of plastic, or do you mean
Yeah. A person made of microplastic. So it's actually not a small person. It's a regular sized person, and they're completely made of microplastic.
Got it. There's 3 ways to interpret what you said, not 2. Okay.
No, a person who works with microplastics.
Nice.
To learn some about why do we care that there's microplastics and everything? Are they really bad for us? What can we learn?
That's cool, man. Interesting. I saw a very funny meme that said something like, "The microplastics in me affirm the microplastics in you." Just got this.
That's good.
Great,
Yeah, there's
it's a yoga saying almost with mixed with.
Yeah, with
science.
microplastics. Yeah, that's funny.
This next question is from Eden North America on Instagram. What are some facts about helium-3?
I know that helium-3 is used, I think, in energy production. But the only thing I think about when I think about helium-3 is a book that I read called Red Rising. And it's
We talked about this.
a sci-fi book.
Uh-huh.
And they mine for helium-3. And they use it to try to terraform Mars.
Whoa.
And then they're successful, I guess, technically. So, that's what I know about helium-3. But also, I do know there's helium-3 on the moon.
Mm-hmm.
And helium-3 is valuable. Helium in general is... We did a whole series of episodes on helium being because it's lighter than the atmosphere, it will leave us.
Yeah.
And so it is a non-renewable resource and it's finite.
Mm-hmm.
And so... I've heard that there's talks about should we go to the moon and mine for helium-3.
Mm-hmm. Mm-hmm.
So, because is it more expensive to do that? Is it less expensive, I guess, to do that, to source some helium-3? But I don't know very much about what they use it for or anything like that. But I did immediately think of Red Rising. And if that's why you asked, Eden, I would love to chat about that.
Nice. Cool. Very cool. I mean, they could, honestly, I think it's right there. Marketing term, brand name, whatever you want to call it. If in a future situation it makes more sense to go mine it on the moon, the company could be called Threlium.
Threlium. That's good. Threlium.
It's right there.
How would you spell that?
I would just do THREE and then LIUM. Yeah. Threlium.
Okay.
But you could also do the numeral 3. Threlium.
Yep.
That's
what I was thinking. Yeah.
But people might try to pronounce it Elium,
Oh, yeah.
So unless you did a hyphen or something. Anyway, just send the royalty check to Chem for Your Life.
The poor man's copyright.
Yep. This last one from Instagram, at least, is from AshYC on Instagram. Chemicals or non-chemicals to polish silver jewelry? Good luck using some non-chemicals to polish silver jewelry.
That's a good point. Everything is chemicals, technically. But actually, we have a whole episode on silver and tarnish. And I don't remember very much of it, except that sulfur is what tarnishes it. Sulfur gas in the air. So like if you stick your hand in mayo when you're wearing a silver ring, it would tarnish faster. Do you remember that?
Oh, yeah.
And then we also talked about how you can use, I think it's aluminum foil and something else. But it was a long time ago. It was early on. Somebody was like, I'm buying my girlfriend a ring.
Yeah. I forgot about that. That was good.
Yeah. So go back and check that episode out, because you don't have to listen to me who hasn't thought about it in 5 years. You can go listen to Melissa who knew about it back then. So check that out. That it's an episode on like why does silver tarnish? I think.
Yeah.
I bet I could look up the exact name. It is What is Silver Tarnish? And we first aired it on December 10th, 2020.
Nice.
So go check that out.
Classic. The vintage app right there.
Yeah, that's almost 5 years ago.
This last one is just one long question here, or sort of response. Is that what this one is from the email?
Okay, great. Yeah.
Okay. Let me see what I'm about to say. Okay, this is from Greg Perry, and I'll just read it.
I hope he doesn't mind. We give his whole name a shout out. Maybe you could beep it.
Yeah,
like Greg beep.
I guess we sometimes do, because people just put their username and it like sometimes has their whole.
Or I just do like Greg.
Deal.
I'll like say Greg P or whatever. Yeah.
Yeah. Okay, yeah. This was from beep. Okay. I'm a former chemistry teacher, and I enjoy a podcast that I discovered recently. I've been going through your catalog listening to ones that catch my interest. That's a great way to do it, honestly. If you're someone who is just now discovering us, yeah, we got a lot of episodes. We know that is true, and it can be daunting. It's totally fine to just go through and see which ones jump out to you. And yeah, it's a great way to start if you're like, especially coming from the perspective like a lot of us, where you're like, chemistry wasn't my fave. Then like start with something interesting.
Something that is your fave.
Yeah. So Greg says, I have been making sourdough for about 20 years, and I have a comment about your January 2025 sourdough episode. It's specific to your section on how making sourdough consumes time in a particular way. I just wanted to let you know I make my bread in this way, and it's not at all time consuming. Take sourdough starter from fridge that I put away the last made bread. Last time I made it, yeah. Yep. Mix my sourdough batch, and I feed my starter at this point and let it sit out while I'm mixing the batch, after which I put it back in the fridge. I also use tap water. Let it sit 8 to 12 hours. Shape it and set in whatever I will bake it in. Let it sit 1.5 to 3 hours. Bake. The bowls I use are either glass, plastic, or ceramic, whatever's handy. Rising time depends on the ambient temperature, takes longer in winter. At one point, I read up online advice from other sourdough makers, and I found a wide set of contradicting advice and prohibitions about how to do it, so I eventually just stopped looking. I'm sure there are ways I can improve my bread to optimize things, but my method takes about 15 minutes to make the batch and about 10 minutes to shape it for baking. I arrange my schedule so that the rising time happens either when I'm at work or overnight. Thanks for letting me share.
Isn't that great?
Very cool. And that is the kind of thing that once you've done it quite a bit, I'm guessing, Greg, that the first several times you made sourdough, that it took longer and there was a bit of like, oh, am I doing this right? And just to figuring it out. Sounds like you've got an awesome rhythm. Yeah,
for sure. And actually, I shared that email with my friend Katie at work, who is also starting to make sourdough. So I was like, hey, here's a way that we do that. So she asked about it after listening to that episode as well. So
I'll say, Greg, that you're responding to, I think, the comment I made in that episode about like, I would love to do do sourdough, but it would take too much time. And I do think that the way my life is right now, I think the phase of the figuring out and tinkering and all that kind of stuff, that takes time that I'm not currently super. I could do it, but I'm not. Don't super want to.
But it could also be for Mason because Mason said that he doesn't do it anymore because he doesn't have his work from home day and it takes too much time.
Did he still have it back then though?
No.
Okay.
I don't think so.
I remember us talking about.
Maybe. I don't know.
We did a couple, didn't we? There was one where Mason was in it.
Yeah.
Yeah, that's a really good point.
So I honestly don't remember. I don't remember when those things changed, but that is another one that could be good. So.
Yeah, for sure. Yeah. Man, super cool. Well, that's all we have.
All right. So should we wrap it up?
Let's wrap it. If you've got a question, a thought, an idea, a comment, a follow-up, it could be a full-on episode or it could be land right here in our Q&R episodes where you get to ask a chemist. Chemistry support, whatever you want to call it. Send those to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts and ideas with us. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. You get an ad-free feed of the show. You get a bonus episode every month. You get a few different perks, different ways of us saying thank you. Most importantly, you help keep the show going and you keep it free for everybody else. And you get shout-outs and stuff at every episode. And we get some great questions from our community.
Yeah.
We love getting to know you guys. So it's cool having you over there. But if you cannot do that, that's okay because there's still several other ways you can help support the show by subscribing and writing a review on Apple Podcasts, subscribing on your favorite podcast app like Spotify or whatever. You can subscribe to YouTube and leave a comment over there saying hello. You can buy some merch on our merch store at chemforyourlife.com/store. And there's a bunch of ways you can support the show, keep it going, and help other people just to find our show and have the chemistry of their everyday life explained to them.
Great. And we like to shout out every one of those people who makes this happen. So thank you to Hunter, Chris, Claire, Steven, Tim, Katrina, Scott, Vince, and some of those people you've heard from today, including Vince and Kyle. Kyle, shout you out. Brian, Latila, Rachel, Elizabeth, John, Jesse, Doreen, Chelsea, Heather, Ash, Emily, Avishai, Chelsea, Christina, Jacob, Venus, Suzanne, Erica, Cullen, Jeanette, Sierra, I was getting that mixed up with Sienna, Sierra, Autoclave, Julie, Justine, our newest member, and Emily. Thank you all so much for all that you do to make this show happen. And there's no show notes, or there might be show notes, I guess, but there's no references for this episode. So go check out our show notes just if you want to see what things Jam puts in them.
Who knows? Who knows?
Who knows?
Yay, chemistry.
Yay, chemistry.